Today you'll be learning about solving systems using elimination, section 3-2 in your book. Elimination is just another algebraic method. We use elimination to eliminate a variable so we can solve for another. To eliminate, you have to have the same number but with opposite signs, like 3x plus negative 3x would make 0 and eliminate. Let's look at an example. 2x plus 3y equals 7 and negative 2x plus 5y equals 1. You could eliminate the variable x and be left with y to solve the equation. The x's would eliminate and we would add together the remaining to get 8y equals 8. And then you could solve and find your variables. So let's try one. Solve by elimination. 4x plus 2y equals 9. Negative 4x plus 3y equals 16. We're going to first eliminate a variable and add together the remaining, then solve. In this case, the variable we're going to eliminate is x, since we have a positive 4 and a negative 4. So let's take our two equations and add them together. When we do this, 4x plus negative 4x eliminates 2y plus 3y equals 5y, which equals 9 plus 16, which makes 25. Then we would take 5y equals 25, divide by 5 on both sides to find that y equals 5. Second, we would substitute that answer into an equation to find the remaining variable. We know what y is, so now we need to find x. So we can take 4x plus 2y equals 9 and plug in y equals 5, so that it becomes 4x plus 2 times 5 equals 9. Which would make 4x plus 10 equal to 9. Subtract 10, 4x would equal negative 1. Divide by 4, and x would equal negative 1/4. So now that I know what x and y is, we write our answer as the point negative 1/4, comma, 5. Now you try. Open your book to page 144 and try Got It number 3. Remember to pause the video so that you can try the answer and look your answer up in the back of the book. When you are ready, hit play and continue on. Let's try another solving by elimination. But this time, we do not have opposite signs. As you see, we have an x and an x, which will not eliminate, and we have a 2y and a negative y, which also will not eliminate. So this time, we need to multiply one of the equations by negative 1 to get opposite signs on x. If we do this, then x will eliminate. So let's take the first equation and multiply it by negative 1. Make sure that you multiply by negative 1 on both sides, so that the new equation becomes negative x minus 2y equals 1. All of the signs changed. Then we can add it together with our second equation. So we take our first equation and our second equation. And now we can eliminate x. Negative x plus x makes 0. Negative 2y plus negative 1y makes negative 3y, which equals 1 plus 8, making 9. And then we'll solve for y. Negative 3y equals 9. Divide by negative 3. and find that y equals negative 3. So now we know what y is. We need to go and find x. So we're going to plug in our answer for y and solve for x. We can take the first equation or the second equation. So if we take the first equation, we get x plus 2 times negative 3 equals negative 1. This makes x minus 6 equal to negative 1. Add 6 and find that x equals 5. So the answer would be 5 comma negative 3. Now you try. Turn to page 146 and do number 23 in your book. Here's one last example of solving by elimination. Notice that in this example, neither x nor y share a common coefficient. So just making one of them negative will not eliminate. We need to change one or both of the equations so that the numbers are the same and with opposite signs. So what we're going to do is we're going to multiply one or both equations by some number to get a variable with the same number but opposite signs. I'm going to choose to eliminate x. To do so, 2 and 3 can both become 6 if I multiply them by each other. So if I take the first equation and multiply it by 3, I will get 6x plus 21y equals 12. Then I can take the second equation and multiply it by negative 2. So that I get negative 6x minus 10y equals 10. You want to make sure that one of them is positive and one of them is negative, which is why I chose to multiply the second equation by negative 2, creating the negative 6 that will eliminate with positive 6. So now we can eliminate and add our equations together. So let's take 6x plus 21y equals 12 plus negative 6x minus 10y equals 10. 6x plus negative 6x will eliminate. 21y plus negative 10y will make 11y. And 12 plus 10 will make 22. So now 11y equals 22. We can divide by 11 and find that y equals 2. So now we know what y is, we need to find x. We can plug y in to one of these two equations or one of the two original equations. So let's plug our answer in to the first equation. Let's take 2x plus 7y equals 4 and plug in the 2 for y. So it becomes 2x plus 7 times 2 equals 4. 2x plus 14 equals 4. Subtract 14. 2x equals negative 10. Divide by 2, and x equals negative 5. So now I know what x is and y, so I can write my answer as the point negative 5, comma 2. Now you try. Turn to page 145 and you got it for A. One more thing that I would like to remind you about is that sometimes you can have special solutions, like infinite solutions or no solutions. In the first example, if we try elimination, 2x plus negative 2x would make 0. Negative 6y plus 6y would also make 0. And then 9 minus 9 would make 0. You would end up with 0 equals 0, which is always true, which makes the solution be infinite solutions, because 0 will always equal 0, which means infinitely. If we look at the second example, when we add these two equations together, negative 3x plus 3x would make 0. Negative 5y plus 5y would also make 0. But this time it equals 7 plus 8, which is 15. 0 does not equal 15. That is never true. So this time the answer would be no solution. This completes your notes for section 3-2, part 2. Now you are ready to try the 3-2, part 2 assignment. Bring in your questions to class tomorrow and make sure that you have everything written down and ready to go.